1.6, the algebra of functions. All right, so are you tired of the F word yet?
Yeah.
Yes.
Yeah, functions you will hear forever and ever. Amen. That and factor. I was waiting for somebody this morning in chapel when Mrs. Rowley or somebody was asking a question for the Jesus or the factor to come out, but it didn't. I was sorely, yeah, that's true. It was kind of a serious thing. All right, so if we have f of x equals x plus 2, and we have g of x equals x squared plus 1. Okay, so does that mess you up, me having an f of x in one equation and a g of x in another? Okay, all that means is I'm talking about two different functions. We're both, I mean, you could write them both as f of x, but the problem is you wouldn't know which one we're talking about. So that's all the g of x is. It's just another f of x. So, I mean, you could write f of x subscript 1 or something like that, but they don't. They just give you all these different letters of x, and not really that big a deal. It's just saying we've got two functions. We've got an f function, and we have a g function. Okay, so what is f of 3? 5. What is g of 3? Okay, so you get that when I put a g in there. When I want the g of 3, that means you plug it in the g function. The f, you plug it in the f function. Okay, so not rocket science there, but can be. What would f of 3 over g of 3 equal? Okay, Erica says 1/2. Why do you say 1/2?
So that's 5 over 10.
Okay. So you just find the f of 3 on top, g of 3 on bottom. Yes, Kelsey? Let's put, well, since Kelsey's leaving, let's do some harder ones here. All right, so let's do f of x equals, and again, this is back old algebra stuff, and we'll kind of continue on with. Okay, f of x is x plus 1, g of x is the square root of x plus 3. All right. What if I am interested in that? The sum of those two functions. Well, the rule says that equals f of x plus g of x. Okay? So that being the case, what would it look like if I had f plus g of x using this bunch of stuff up there? All right, so we're going to substitute x plus 1 for f of x. We're going to substitute the square root of x plus 3 for our g of x. So that is f plus g of x. Just sticking them together with an addition sign. Same thing you would do with a subtraction or a multiplication. So what you would do is whatever sign you're dealing with, you're just going to put it in there and to separate the two functions. Okay, division is a little bit different. Why in the world would there be a little bit more of a problem with the division part? Can you think of a reason? Okay. The reason that the division is different is because the denominator cannot equal what? 0. So whether or not this actually works depends on what your domain is. Okay? Because your domain for your f of x may be one thing, your domain of your g of x may be something else, because it can't be a number that makes that denominator 0. So sometimes it's not the set of real numbers as your domain. It may be the set of real numbers, but 3 and negative 3 don't work. So we have to be a little bit careful. We'll get into more detail about how all that works in a minute. But anyway, let's at least look for a minute at the domain there. Let me write that up here again. F of x equals x plus 1, and g of x equals square root of x plus 3. Okay, we just had that up there. Okay. We put those together as f plus g of x a minute ago, and you found out that that was x plus 1 plus the square root of x plus 3. But let's say we make a little bit of a difference here and do f plus g of 6. How is that different than the one we just did right there?
There's a number.
Okay. Yeah, so instead of just having x plus 1 plus the square root of x plus 3, we're going to have 6 plus 1 plus the square root of 6 plus 3. All we're doing is substituting that in for x. So whatever is in that parenthesis, you're going to substitute into the function. So that being the case, we get 7 plus 3 equals 10. Okay? So when I combine those functions through addition, I'm going to get 10. Okay, so let me give one to you to do all by your lonesome. F plus g, and we'll do it with negative 4. Alright, so because of the square root of negative 4 plus 3 makes that a negative 1 under the radical, which means it's not a possible answer. So we throw that out. Alright. When you're looking at the domains, when you're adding or subtracting your functions, make sure that you realize that your domain will be the intersection of your two domains. So, for instance, we have an f of x domain and a g of x domain. So your domain, when you combine them by adding them, is going to be the intersection of those two. So, for example, what is my domain of f of x equals, let's look at the first one, x plus 1 that you just worked on. What's the domain of that? All real numbers. Okay? What's the domain of my g of x when I had the square root of x plus 3? What's the domain of that? Okay, so the domain then would be negative 3, including negative 3, ergo the squared off bracket, to positive infinity. So, if I'm looking at the domain of both of those, of f and g, it has to be where those two domains intersect. Where do they intersect? They intersect right here, right? Because this one says all numbers. This one says all numbers negative 3 and greater. So that's the intersection. That's the commonality between both of those domains. And that's what you look at as far as intersection. Where do they have that commonality? Where does it work for both of them? That's the intersection. Okay, so the domain for f plus g is that one. Like my scribbles all over the place. Okay, so page 136, middle of the page, has a little box there. If f and g are functions, then the domain of the functions f plus g, f minus g, and f times g are each the intersection of the domain of f and the domain of g. the domain of f over g, f divided by g, is also the intersection of the domains f and g, with the exclusion of any x values for which g of x equals 0. Okay, so does that make sense? You want me to explain it a little more? It's important to get that. Okay, so the plus, the minus, and the multiplication are the intersections. The division is also the intersection, as long as you make sure that you throw out any time that bottom number is 0, because that doesn't exist. Okay, so given that f of x equals x squared minus 4, so I'm giving you that information, and g of x equals x plus 2. All right, what it's asking you to find is each of the following. I'm on page 136, middle of the page. If you want to follow the example, if you just want to watch what we're doing up here, that's fine. They want to know what the domain of f plus g is. Okay, so what's the domain of f plus g? Are there any numbers that do not work for either one of those? Okay, x squared minus 4, is there any number that makes that undefined? No. Because what makes it undefined? The denominator is 0, or the square root is negative. We don't have either. So f plus g is, f of x, the domain of f of x is real numbers. What about g of x? What's the domain of that? Also real numbers. There's nothing that's going to make that undefined. So, the domain f is a set of all real numbers. The domain g is a set of all real numbers. Therefore, the intersection of real numbers with real numbers is real numbers. Okay, so there's nothing that you're taking out there. All right, we'll continue on with the second part of this tomorrow.